This video is for the lesson 8.7 homework. Get this set here. Okay, so what we've got to do on these is we've got to write an equation for the situation, and we've got to find different pieces. Okay, so with projectile motion, there's two options. If they give us the information in feet, okay, they give us the information in feet, our equation's going to start with negative 16. And then we use a t here for time, okay? So these are going to be, let's see, a t squared plus b t plus c. So the a, I think with this, a is going to be the force of gravity. So if it's feet, if they give you the information in feet, that a value is going to be a negative 16. If they give you that information in meters, that number is going to be a negative, make sure I'm right here, negative 4.9. The b value is, I'm trying to think of the best way, the velocity. We can use the word velocity. So how fast the thing is going. And then c is the starting height. Okay. I'm going to grab a better pen here. That one. Okay. So since this one is feet, that's why we start with the negative 16. All right. So negative 16 t squared. Velocity comes next. So initial upward velocity of 16 feet. So my b value is a 16. And we use a t instead of an x. And then starting height. So if Eric jumped off a 96-foot cliff, he's starting 96 feet above the ground. So plus 96. The easiest way to do these is to graph them. Now, when you graph, you do have to use an x. You can't put a t in these. So negative 16x squared plus 16x plus 96. And then I'm going to zoom out a little bit. Menu 4, 4. Because I like to see the very top of these. Okay. So what we have is we have a parabola. So if these are my axis, my x and my y, this thing does something like this. Okay? On this problem, though, we're starting at 96 feet above the ground. So that's my starting point, and he's going to jump into the water. Okay? So imagine a little dude standing here, and he's going to jump into the water. So number 2 says, what's the maximum height that Eric will reach? The maximum height is the vertex. Okay? So in the calculator where we type this in, we can find the vertex. Is the vertex here, is it a minimum or a maximum? Maximum. So if we do menu 6, 3, I get 0.5, 0.5, comma, 100. Okay? So the first number in these ordered pairs that you get, x comma y, the first number is talking about the time, and then the y value is talking about his height. So his maximum height is the second number, the 100 feet. How long will it take Eric to reach his maximum height? So that's the first number. That's the 0.5. 0.5, and it's going to be seconds. And then how long will it take Eric to reach the water? So if he jumps, this is where he's going to hit the water. What is that point called on a graph of a parabola? An x-intercept, yeah. An x-intercept, a 0, all that good stuff. So, menu 6, 1, we're going to find the 0. And that 0 is at 3, 0. So what's it say? How long? How long will it take Eric to reach the water? So again, the x, that's your time. So it's going to take him 3 seconds. So when they're talking about projectile motion, the pieces you need to be able to find: the y-intercept where he starts, the vertex, that's going to be his highest point and how long it takes him to get to his highest point, and then the x-intercept, how long it takes to hit the ground. Okay, and that's the first number. Okay. All right, number 5. Some fireworks are fired vertically into the air from the ground at an initial velocity of 29.4 meters per second. Write a function. So again, meters tells me this is going to start with the negative 4.9. So that's what I start with. Negative 4.9 t squared. Velocity is my next number. That's my b. So plus 29.4 t. And then if they're shot from the air, so remember the c value at the end is the height off the ground. What's the height off the ground if I shoot the fireworks from the ground? If I'm standing right here and I jump from here, how high off the ground was I when I started? 0. So if what you're shooting or what you're firing or what you're hitting is starting at ground level, you don't have a C because it's plus 0. Okay? All right, so here's what this one looks like. Since this one starts at the ground, that's my starting position, 0, 0. 0 seconds, I'm 0 feet off the ground. Here's the highest point they reach, and then here's when they hit the ground. So I can graph the equation that I wrote, negative 4.9 x squared plus 29.4x. I know I write a t. Your calculator will not take a t on the graph. You have to change it to x. All right, number 6 says, what's the maximum height? So again, maximum height is your vertex, and it's going to be a maximum, okay? So you can also, it's hard to do on those calculators, you can grab the screen and kind of pull it down if you don't like zooming out. But you have to be able to see that maximum before you can do the menu 6, 3. You've got to be able to see that point on the graph. All right, so that point is 3, 44.1. So what's the maximum height they're going to get? 44.1. The second number is your height. All right. How long will it take the firework to hit the ground? So that's over here. It's getting shot. Highest point comes down. So now I got to find the x-intercept. So I'm going to kind of drag this thing back down. Again, you can zoom out. You can do menu 4. So menu 6, 1. I want to find this point. That point is 6, 0. So how long will it take for that firework to hit the ground? And then how long will it take for the firework to be 33.075 meters above the ground? So height is a y value. So with questions like this, what you can do in your calculator, you can pull up the table. Okay, so here's where we're starting. And we can look for the 33.075, and it's not on there. So I can't take the easy way out on this one. What I can do is I can set my equation, negative 4.9 t squared plus 29.4 t. I can set it equal to that amount. Okay. And then I can solve this using the quadratic formula. We have officially come full circle. So when we use quadratic formula, we need all the pieces together. So subtract 33.075 from both sides, because remember, we need all the pieces and we need one side to be an A. So this is A, this is B, this is C. So quadratic formula is negative b plus or minus the square root b squared minus 4ac divided by 2a. All right, so b is 24.9 plus or minus b squared, so 24.9 squared. A is a negative 4.9. C is a negative 33.07. Oh, I'm running out of room. 075 divided by 2a. Okay, so remember with quadratic formula, you got to type it in twice. So on the calculator side, put a fraction in, and I'm going to type it in just like that. So negative 24.9. Do a plus sign. When you do it the second time, change it to subtraction. 24.9 squared. That's 4. Times negative 4.9. Crud. Where'd I get off at? Did I type something in wrong? Because it's not a non-real. Only way I can check it. And I'm off somewhere. Type just the parentheses in. You can when you're finding the discriminant, but this one should be a real solution. It shouldn't be a non-real solution. So I messed up somewhere, and I don't know where I messed up at, which is never good, because then I can't, it throws y'all off. All right, I'm going to show you one other thing you can do in your calculator really quick when all else fails. In the graph, you can change the table. So if I open this table up, see how my X's are 1, 2, 3, 4, and 5? I can hit menu and go table and then edit table settings. And so here where it says table step 1, it's counting by ones. The X's are going up by ones. So I can change that. I can change it to a half, 0.5. I could change it to a fourth, 0.25. But there's that value I was looking for, that 33.075. But there's going to be two of them. So it's going to hit 33 feet going up, and it's going to hit 33 feet coming down. So going up, the first time it hits it, it's going to take 1.5 seconds. Coming down, there's the second one. It's going to take 4.5 seconds. So those are your answers on that one, is 1.5 and 4.5 seconds. All right, I'm going to leave you 9 and 10. On number 9, it says Don is trying to throw a ball into a basket that is 20 feet high. The height of the ball he throws is given by the function. So here's your function. Will the ball make it into the basket? You want to find the vertex. Okay, so remember, it's going to be an ordered pair, x comma y. If the y value, the second number, is greater than 20 or greater, he'll make the shot. He'll throw it high enough to get there. If it's that number there is less than 20, he's not throwing it high enough to make the shot. 10 is the same thing. It wants the vertex. It wants to know what that second number is in the vertex. So graph it. Find the vertex. So it's a maximum. So that would be menu 6, 3. If the y value is 20 or greater, yes, he makes the shot. If it's less than 20, no, he doesn't. Then write that value down, what the second number is. Okay?